so that way we're all on the same page. Then we'll go over the two quick check, any others, and then any other review questions. Alright, so again, they're using the perfect square method, so I'll say the answer first, and then if we need to see it the other way, we can do that. So our final answer was -8 times the square root of 3 minus 24 times the square root of 7. I saw a lot of you have that, so good job. You should have been multiplying this -4 to the number outside, the square root of 2 to the inside, and then the -4 to 3, the numbers on the outside, and the -2 to the 14 on the inside. So insides go together, outsides go together, multiplying those, and then at the end, after you multiply those, simplify it if possible, which we could. These both have the perfect square of 4, which would make 2. Multiply those together, and then if we could, or if they have the same radicand, simplify them, combine them, but only the outsides, not the insides. Questions about that one? On the quick check, you guys had to do 3 and 4. Anyone want to share their process and answer for number 3?
So first I factored tree out both of the roots.
Okay.
And so I factored 8x3 to 4 and 2, and then 2 and 2 for 4. And then for 18x3, I factored out to 2 and 9, and then 9, 3 and 3. And then I multiply 5 by 2, and I put my 2 into my x3, which gives me 1x. But next to the 5.
Sorry, you put this, okay. So you did factor tree for the numbers and then the rule for the variables?
Yes.
Okay, so 2 goes into 3 once.
So then I have 1x next to 5 times 2. And then root 2x. And then I multiply my 3 by my 3, so I get 9. And then I also have the same, 2 goes into 3 only once again, so then I have 1x. And then root 2x.
Okay, so this would become 10x times 2 times the square root of 2x plus 9x times the square root of 2x.
And then I add them together to get 19x root 2x.
So the biggest thing with this one to keep track of is what to simplify, what to combine together, multiplying and adding. Here, because we are adding these two together, we cannot do anything until we simplify to see if they have the same radicand, the things underneath the radical. So we simplify. After we simplify, then we see that we have the same insides. Because these also have x's on the outside, they have to have the same number of x's or same variable and exponent, as well as the same radicand. Then if those are the same, the only things we are adding together is the things on the outside. So the inside does not change. The only time the insides change is if we are multiplying. Try to keep that straight. Questions about number 3? Anyone want to share their work and answer for number 4? Go for it, Otis.
Okay, so I multiplied my length times my width. So I multiplied 3 root 6 by 4 root 15. And then when I multiply 3 and 4 together, I get 12. And then
Go ahead.
And then, oh wait, I added the multiply for the root. but we need to multiply 6 by 15. And then we get 90.
So I'm going to rewrite that over here just in case you missed that step. 3 times 4, and then underneath the square root, 6 times 15. And then, Jaden.
And you get
Mm-hmm.
the 9 and 10s.
Did you use factor tree or perfect squares?
Oh,
Okay.
9 and 2. And then the 9 is turned the 9 is turned to 3. And the 10 is turned to 5 and 2.
Okay.
And 3's go inside and 5 and 2 are on the outside.
Opposite. The 3s would go on the outside, and the 5 and 2 would go on the inside.
Which gives us 36 root 10. And then that's our final answer.
That cannot be simplified any further. Good joint collaboration. Jaden.
I did that differently.
Okay. You should have had 3 on the outside and 5 and 2 on the inside.
I didn't have 5 and 2 on the inside. I just like put the 3 down there.
So you took, okay. So here, if you took 9 and 10 and you immediately did 3, this is taking your perfect squares. So you did it like that? Yeah. Regina?
Is this type of question going to be on the quiz?
You will have to multiply, yes. All right. Now, on the review, does anyone need an extra copy of the review first?
Oh, no, I have a question.
Mm-hmm.
When you do I wasn't very
How do we see the 3 out here?
I wasn't told minus 3 minus.
Not minus. This is multiplication. You need one. Anyone else need another copy of the review?
Oh, yeah.
Anyone else need another copy? Do you need one, Hila? Mm-hmm. So I'm going to explain that here in a second. So as we practice these questions on the review, I'm going to say try to practice it without, because the quiz, you will not be using your calculator, but you will have each other. On the review, I want you to find any question you have that you are still not 100% on, you want to go through, you have questions about, anything like that. Starting on the first page. Hila. Pen. Jasmine. 9. Alright, so we'll start with those two. Here we are adding and subtracting radicals. This is your radical operation, the second objective. Number 9, can we add or subtract these as is? No, so we have to simplify. Whether you do that factor tree or perfect squares does not matter. I'm going to do 48 and 50 using factor tree, and then 147 using perfect squares. You can do them all perfect squares, all factor tree, mix, it does not matter. All right, so give me 2 factors of 48. 24 and 2. Wow. 2 factors of 24. Say it again.
64, 12, and 2.
Okay, you could keep doing 2s all the time, sure. 12 and 2, 2 factors of 12,
4 and 3.
6 and 2, or 4 and 3, does not matter. So then we can break down our 6 to 3 and 2 and 3 and 2. So we have a pair of 3s, pair of 2s.
Where did that
It's
six
supposed to
come
be
from?
12 and 2, not 12 and 6.
Yeah, it definitely is. So I was like, that's wrong. Okay, second. So no pair of 3s. We do have a pair of 2s. And another pair of 2s. There we go. That looks better. Because everything was about to become pairs, and I was like, that's not right. Alright, so we have 4 times our one group of 2s, our second group of 2s, with 3 on the inside. We'll simplify at the end. Now, think perfect squares. What is the highest perfect square we can divide 147 by? Jada?
49.
49 and
30.
49 and 3. Right, so this would be negative 7 times the square root of 3. And then if we're breaking down 50, give me 2 factors of 50. Say that again.
5 and 10.
5 and 10, sure. And then 5 and 2. So we have a pair of 5s. We have negative 3 times 5 times the square root of 2. And then we need to multiply everything and start to simplify. So 4 times 2 times 2 would give us 16. Square root of 3 minus 7 times the square root of 3 minus 15 times the square root of 2. Do we have like terms we can combine? Yes, which ones?
16 and negative 7.
The ones with the 3s. So if we combine those two, what would we get? 9 root 3. I don't know if you can see this color or not. 9 times the square root of 3 minus 15 times the square root of 2. We cannot combine those two, so that would be it. If you switch the order of these, that would also be okay. But you would just have to make sure the signs match. So negative 15 times the square root of 2 plus 9 times the square root of 3. Either or. Questions on that? If you are getting lost anywhere, now is the time to ask questions. Keela.
Where did you get this?
This one came from, sorry, which one are you talking about? This one or this one? Was 7 or 15? 7. This one was already there. So we just brought it. Okay. Jasmine.
How do you know when to add like 16 or 17 or minus something?
Okay, so here, my operations are minus and minus. So at the end, I want to see if I can subtract. I'm not multiplying anything except for the things that are already next to each other. So the things that are already next to each other, I'm going to be multiplying those. Which is why we ended up multiplying to get 16 and negative 15. Here, though, there's nothing to multiply. These are already multiplying together because they're next to one another. But everything else is either we subtract or we don't. So we're just looking for, do they have the same radicand or not? So this one does not, so we would add, subtract these two, but only the outsides, not the inside. Did that help? Okay. Okay, and then,
But adding and subtracting radicals beyond the quiz.
yes. Regina? Yeah. Do that, you help us? Let me get my iPad together. Okay. Let me know once that goes through. Alright, same thing. Number 10. Can we add those or subtract them together as is? No. Can we simplify the square root of 5? No. So we can skip that one, move on to the next one. I'm going to do perfect squares for this one, and then we can do factor tree for that one. Jaden?
25 and 5.
25 and 5. So that would give us 5 times the square root of 5. So I'm going to rewrite this up here. 3 times the square root of 5 plus 7 times 5 times the square root of 5. Regina, go ahead. Jaden, go ahead.
And 45 would be 9 and 5.
9 and 5. But I'm going to use factor tree, not perfect squares. But if you did factor tree, perfect squares, that's fine. So we would have a pair of 3's that comes out. So this would be minus 2 times 3 times the square root of 5. And then we can multiply and see if we can simplify anything. 3 times the square root of 5 plus 35 times the square root of 5 minus 6 times the square root of 5. Can we combine anything? Yes. Jaden, go ahead.
The 35, 3 and also the 5s.
So the 5's would stay the same, but we can combine all of these because they have the same radicand, yes. When we combine that, what would it be? Go ahead.
32 times the square root of 5.
I believe that's right, 38, yep. 32 times the square root of 5. Questions about any of that process? Again, if you are lost or confused, now is the time to ask questions. Can you do 13? I can. Alright, for 13, we are now multiplying. Okay, so insides together, outsides together. Here we don't have outside things, so there would just be a 1, or you can leave it blank. The insides, we're going to put all of that together. 5 times 8 will give us 40. Anytime you're multiplying these variables, just add the exponents. So this would become x to the 5th. Now we just need to simplify. So if we're using perfect squares, give me the highest perfect square we can divide 40 by. Yes. Right. So this would become 2 times the square root of 10. And then either use your factor tree method or think about your rule, either or. I'm going to do the factor tree method for this since it's small enough. This would be 5x's. I'm looking for pairs, so I have 2 of them. So that would be x times x with 1 left over. So everything on the outside, I have 2. If I combine these, I'd have x squared. On the inside, we have 10x. And that would be our final answer. Questions on that one? About the process, about the answer, anything like that? Other questions on the first page before we move on to the second? Jaden.
Read number 6.
Number 6. I said if you get a bigger number and aren't sure about the perfect squares, start using factor tree. Because I know that I can, a couple things. I know that I can easily divide this by 2, or this ends in a 0, so I can easily do 32 and 10. Try to look for easier numbers instead of 2, that way you don't end up with huge numbers. So then we have 4 and 8, 2 and 2, 4 and 2, 2 and 2, 5 and 2. Remember, this is a cube root, so we're looking for groups of 3. We have 1, 2 groups of 2 that get to come out. With 1, 5 left inside. For your variables, if you want to list them all out and find your groups, you can do that. But since there's 15, I'm going to use the rule instead. If you want to still do writing them all out, go for it. 3 goes into 15 how many times? 5. That's going to be an even, not 5's not even, but there wouldn't be anything left over. 3 goes into 7 how many times? Twice. And there'll be how much left over? Once. 1. I don't know why I said once. Rewriting everything that's on the outside, we have 2 times 2 times m to the 5th times n squared. So 4 m to the 5th n squared times the cube root of everything inside, 5 and n. So 4m to the 5th n squared times the cube root of 5n would be our final answer for that one. Do we have any questions on that one? Process, answer? Emmett?
Could you put m to the 5th then n squared then 4?
No. So we want the number to go in front and then our variables. Jaden?
I don't get how we get the n squared.
The inside part? Or I'm sorry, the n squared. Okay. Think about
Yeah, the inside one.
the inside part. Okay. 3 goes into 7 how many times? Well, what did I just do? So think about evenly. So if I put it in once, that's 3. If I put it in again, that's 6. Could I put it in 3 times? No. So it could definitely go in twice. And then if I put it in twice, that would be 6. But I need it to go up to 7. So there would be 1 left. Okay. Other questions on that one? Other questions on the first page? Move on to the next one. Questions on 14 through 17. I'm sorry, you guys' page is different. This is on the very last page, so look at that, and then we'll come back to that. I think it's at the bottom, but I think it's labeled differently. I could be completely wrong. Yeah, it's numbers 13 through 16. Sure. Gila. My 14 or yours? Mine. Okay. So in this case, we are distributing outside numbers to outside numbers, inside numbers to inside numbers. I should probably use 2 different colors. here we don't have another inside thing, so there's only one. So here, we would be multiplying these two things together, all of it, but outside numbers together, there's a 1 there, so I'm multiplying 1 and 7. And then on the inside, I'm multiplying 6 and 3. I promise you I'm changing these colors, it's just not working. There we go. For the second one, I'm multiplying my outsides together, which is 1 and 6. I don't have an inside, so I would just put the square root of 6. And then we are now adding these two together, so we need them to have the same radicand. They don't, so I need to simplify 18. So I'm going to use the perfect square method. Bring down my 7 because I need to multiply that. It was outside of that square root. So this would become 21 times the square root of 2. I would bring this next to it. 6 times the square root of 6. I cannot simplify either of those again. They are not like terms. I can't combine them. That would be my answer. I know I did that fast. Questions on that one? Otis?
I'm doing here 16 and 17.
Jaden?
How did you get the square root of 6?
The square root of 6. So here when I'm multiplying this entire thing, I'm going to do this in a different color. When I'm multiplying this here, I'm still multiplying my outsides together, which would be 1 and 6. But here I don't have an inside. So I would just be bringing this down. I like put it next to it. I don't really multiply it to anything. I just move it. It like follows it.
If you don't have it there, would it change it?
If you only had 6 and not the square root of 6,
Yeah.
yes, that would change things and that would be wrong. Okay, other questions about that one before we move on? Hila. Say that one more time. You have to know that there's a 1 out here. You have to know that you're multiplying the outsides together. So things you have to know. Jasmine.
How did you get this 18?
Multiplying the 6 and the 3 on the inside. Okay. 16. Here you have to multiply, I'm going to do this and then I'm going to rewrite it. We have to multiply 5 to this first term and this second term, but also this to both of these. So we rewrote it so it looks a little nicer. So we're going to take 5 and multiply it to everything in the second set of parentheses. And the second term, and multiply it to everything in the second set of parentheses. So we're distributing both numbers twice.
For your equal class, because I have a class.
Okay. Distribute 5 here and 5 here. You're just multiplying these numbers together. Here, this would be a 1. You're multiplying the outsides together. 5 and 1 would give us 5, but this was minus. I would just bring down the square root of 7. Regina.
Can you tell me can you stop my time?
Yeah, I did already. Same thing for this one, except you're multiplying outsides together and insides together. This one doesn't have it inside, but this one does. So here, when we multiply the outsides, we'd have 8. And we would just bring down the square root of 7 because it doesn't have another inside to match with it. Here, I have a 1, so I'm multiplying 2 and 1, but it's negative. But on the inside, I have 7 and 7. Questions so far before we do the next step? Jaden.
How did you get the 5 outside?
Okay, so here, when I'm multiplying 5 to the square root of 7, I'm only multiplying it to the outsides, not to the inside, because I don't have it inside. Same thing here. I'm multiplying this 2 to the invisible 1 that is there.
No, like at the start, like at the 16. Like, why did we move it up?
Why did we rewrite it like this? To make it look nicer. I don't know if that looks nicer. Because we haven't actually talked about what this method is yet. Regina?
Is this kind of pushing are they?
Not the double distributing, no. A distributing problem, yes, but not the double. On the quiz, I can't say that for the test. I don't remember for the test. I'll look though. Okay, other questions so far before we continue? Okay. So I'm going to bring down 20. This can't be simplified, so I'm going to just bring that down. This can't be simplified, so I'm just bring that down. We can simplify this because this is a perfect square. Usually in these type of problems, you end up with 2 whole numbers and 2 things with radicals. What can we combine here? Jasmine. Correct. So if we combine these two, what would we get? Not minus 3? It is 3, not minus. Because we're adding. Otis?
Did we miss the -2?
Right here? Is that what you're talking about? What -2? We do have a -2 right here, but that's the only -2.
Never mind.
What else can we combine? Emma? 20, not the 3 because that's connected to the radical, but the 20 and the 14. So that would be 6 plus 3 times the square root of 7. That number would go in front just because it gets confused or lost in the end. And that would be your final answer. Questions about that? That process, how we got that answer? I'm not going to do 17 because it's not going to be on your quiz. We can go over that at a later time because I want you to have enough time to take your quiz. Do we have any last minute questions we want to go over before you guys take your quiz? Emma.
How many questions are on the quiz?
4. Jaden.
Do we have a calculator?
No. So I would say go ahead and put your calculators up right now. Unless you know for a fact that you're not going to be tempted to use it.